Every day, we eat food from the supermarket without much thought about the long and complex supply chain that brings it to our tables. Food contamination by unwanted microorganisms poses significant risks to consumers' health. Consumption of contaminated food products can cause foodborne illnesses, which can range from mild gastrointestinal discomfort to severe health conditions, and in extreme cases, even death. Welcome to the Government Analytical Services, or GAS, part of the Ministry of Agriculture in Barbados. They ensure safe agricultural practices and high food quality standards by analyzing food, water, and environmental samples, identifying potential health risks, and supporting farmers in maintaining safe standards.
Each week, we have a precise routine to ensure all vegetables are tested correctly along the protocol and all delays are respected between the different testings. On Monday, we drive to the supermarket, selecting 2 or 3 pieces of lettuce or other leafy greens such as cabbage, spinach, and kale. We then head to the laboratory to start our sampling. Here's our team ensuring that 25 grams are sampled from each product. We first cut the produce using a sterilized knife and put it directly in a sterilized plastic jar, making sure it is correctly labeled, and finally, pour the sample in a jar containing growing medium. Finally, the samples are incubated at 35 degrees Celsius for 24 hours. The next step is to prepare the growth medium for the following week. For this, we dissolve 40 grams of buffered Peptone water in 2 liters of distilled water. We then pour the medium in 8 glass jars for each sample, without forgetting the positive and negative controls as well as the spiked sample. Everything finally goes to the autoclave for 15 minutes. On Tuesdays, we go back to perform the PCR and streaking of the samples on Petri dishes. As you can see, we plate the sample on 2 different media, McConkey agar and CD SMAC, selected for E. coli 0157H7.
Key results. After our day in the lab, we gain our results. Whether E. coli 0157 was found or not. Would we find anything in our local or imported lettuce? In supermarket A, 4 samples were collected, 2 local and 2 imported. After the PCR test, we found our answer. While our negative showed the value too low to be E. coli 0157 and our positive and spikes showed high concentrations of the bacteria, our lettuce samples showed no presence of the bacteria. Streaking was done to confirm that the bacteria seen was not E. coli 0157. There were yellow colonies, those unable to ferment lactose, and pink colonies, which were coliforms and other E. coli strains. Based on the results of the PCR graphs and the streak plating, it can be concluded that E. coli 0157 was not present in the vegetable produce spot. In supermarkets B, C, D, and E, the same trend was observed. According to PCR tests, E. coli 0157 was absent from all the samples. However, the growth of colonies on the Petri dishes indicated the presence of either coliforms or more likely other bacteria, such as Salmonella or Proteus, as the medium turned yellow, which is not typical of coliforms. To improve this research, extensive testing of the bacteria found would be required. Indeed, our research, which targets the E. coli 0157H7 bacteria, only does not encompass other strains of E. coli detrimental to human health, as well as other bacteria present that could cause health complications. E. coli 0157 is a bacterium that causes severe health issues and is especially fatal to a vulnerable population of children, sick, and the elderly, with contamination leading to widespread outbreaks of illness if not detected early enough. Research like ours help health authorities trace the source of contamination or make a source of contamination known. This will help prevent more people getting sick and protect the public health of citizens.
Unfortunately, our research focused solely on supermarket products, limiting our explosion to the typical supermarket supply chain and excluding other sectors. In our last week, while heading to investigate the farmers' market in Bridgetown, we were unable to collect samples because the market was closed due to a hurricane. After unsuccessfully searching street stores for leafy greens, we decided to shift our focus back to supermarkets. We believe that data from the farmer sector will have been a valuable addition to our project. allowing us to draw more insightful conclusions about possible contamination sources and offer more robust recommendations. To improve this project, we suggest collecting leafy greens from more diversified sources across the island, including but not limited to supermarkets, local farmers markets, and street vendors.
We would like to thank Philip Beckles, our mentor, and Beverly Wood for providing us with this project, Nathan and Dwayne for helping us in the completion of preparation steps, Derek for driving us around the island to collect the samples, and Caroline and Jeff for organizing this project.